There's this incredible, invisible force that literally powers our entire civilization. It's this magic connection between magnetism and electricity. And once you get it, you'll see our modern world in a whole new way.
I mean, think about it. Every single light in your house, every device, the screen you're watching this on right now, it all runs on electricity. But have you ever really stopped to ask, where does all of it come from? How do we make the massive, constant river of energy that our planet runs on?
Well, you might be thinking it's something super complex, right? But the answer, at its very core, is shockingly simple. Almost all the electricity we use comes down to the relationship between just two things: a simple magnet and a coil of wire. That's it. That little pair is the engine behind our whole world.
So, to really get this, we've got to jump back in time to the 1830s and a brilliant scientist named Michael Faraday. He was just driven by pure curiosity, and one of his experiments, well, it accidentally changed everything.
Okay, so what Faraday did was actually pretty simple, but totally profound. He saw that if you just let a magnet sit next to a coil of wire, nothing happens, zero. But the second he moved the magnet, pushed it in or pulled it out, the needle on his meter would jump. It wasn't the magnet being there that mattered, it was the motion. That change was somehow creating an electrical current out of thin air.
And boom, that little observation became what we now call Faraday's law of induction. The key word here is changing. A magnetic field that is changing inside a loop of wire creates or induces a current. And here's the kicker. The faster you change that field, say by moving the magnet quicker, the more current you get. This is the absolute bedrock of how we generate power. But wait, there's a twist. This new current doesn't just flow in any random direction. Oh no, it follows a very specific, almost stubborn rule, which another scientist, Heinrich Lenz, figured out. And it tells us something really deep about how the universe works.
So Lenz's law is basically nature's way of saying, I don't like change. The new current creates its own magnetic field to literally fight back against whatever caused it in the first place. So if you shove a North Pole at the loop instantly creates its own North Pole to try and push you away. It's an automatic pushback.
Yup, it's that simple. Nature just plain resists change. And this is really all about the conservation of energy. It's nature's way of making sure you can't get something for nothing. You have to work against this resistance to generate that power.
Okay, so we know moving a magnet near a wire works. But what happens if we flip that? Keep the magnet still and move the wire instead. Does it still work? And there's this brilliant way to think about it. Just picture the invisible magnetic field as this huge field of long, straight, noodles. If you take a wire and you slice it through those noodles, you create a current. It really doesn't matter who's moving, the magnet or the wire, as long as that wire is cutting the noodles.
So this whole effect has a name: motional EMF, or electromotive force. What's happening is that as the wire moves, the magnetic field is literally sorting the charges inside it. It pushes the positive charges to one end and the negative charges to the other. And just like that, the wire becomes a little temporary battery with a positive and a negative end. But remember nature's rule: no free lunch. The moment that current starts to flow in the wire you're moving, it creates its own magnetic force that pushes back against you. You can actually feel it as a drag or resistance. To keep generating electricity, you have to constantly put in work to push that wire. The electrical energy you get out comes directly from the physical energy you put in. All right, so let's put it all together. We've got a changing magnetic field creating a current, and we know that nature pushes back. Now let's see how this one simple idea scales up to power, everything around us. So instead of just pushing a wire back and forth, which is kind of clunky, what if we just spin it? That's the heart of a generator, really. You just spin a big coil of wire inside a magnetic field. With every single turn, the wires are just constantly cutting through those magnetic noodles, first one way, then the other. It's a beautifully efficient way to turn spinning energy into a steady flow of electrical energy. And once you see it, you'll realize this single principle is, it's everywhere. Those giant turbines at a hydroelectric dam or a wind farm, they're just spinning huge coils in magnetic fields. The transformers you see on power poles, same idea. Your induction cooktop, your wireless phone charger, even the electric motors that run everything from your car to your toothbrush, they all run on this one beautiful fundamental law. It's just amazing, isn't it?
From a little twitching needle in a lab almost 200 years ago to our entire buzzing, electrified world, it all comes down to that beautiful dance between magnets and motion. This discovery is still the engine of our modern world. And that just leaves one big question: what discovery will be the engine of the next one?